Hello, we are Team Dirty Water, and the challenge we selected was the second topic discussed in lecture for providing access to clean drinking water. We decided to focus on India's impoverished population that is forced to consume contaminated water. India is facing a multi-dimensional water crisis, with issues ranging from management to treatment. Lack of drinkable water stems from India's booming population growth, droughts, agricultural practices, and social traditions like open defecation. Overall, India currently has little control over what is dumped into their surface water sources. Raw sewage and industrial runoff is thrown directly into rivers and streams, untreated. Our water treatment solution addresses heavy metals, volatile organic compounds, VOCs, fine particles, and compounds that cause taste and odor issues, like hydrogen sulfide. Traditional methods of boiling and UV natural radiation can reduce the bacteria once the water is passed through the filter. The benefit to our design solution is that it enables poorer populations to treat their own water to make it safer for consumption. We will start with a contained vessel filled with 4 layers of filterable media to remove harmful impurities and improve the aesthetics of the water. As mentioned before, the remaining bacteria can be eliminated through boiling or leaving it in the sun for a couple days. This last step is critical for drinking water provided to small children, whom are very susceptible to waterborne pathogens. We envision our system to serve smaller villages, around 1,500 people. The filters would be constructed around a 30-gallon steel barrel, 2/3 of which would contain filter media. Starting from the top down, we will have 8 gallons of gravel, 4 gallons of smaller gravel, 4 gallons of sand, and 4 gallons of activated carbon. The top 3 layers will be effective for removing larger particles, while the activated carbon will absorb the smaller compounds, the VOCs, the heavy metals, fine sediments, hydrogen sulfide, and the other taste and odor components. The media will require replacement and sterilization, while the barrel will need monthly maintenance. This can be addressed by training locals and providing them with the necessary equipment to manage this themselves. We propose building/buying a facility to serve multiple villages. Here is where the media vessels can be constructed and serviced, and a small fleet of trucks will continually travel to villages and change out spent media filters with new ones. They will take back the filters and sterilize, and also replace the media. The reasoning behind our very simplistic design was to enable it to be constructed and maintained very cheaply. It was important that the media that we chose to filter out impurities could be produced locally or bought locally. Sand and gravel make an excellent choice for cheaply removing the sediments, and it also prolongs the life of the activated carbon, which is the most expensive element of the filter. We designed our vessel to have a drain on the bottom opposed to a faucet that you could turn and stop the water. We did this to remove all the water from the activated carbon to make sure that its life is prolonged. Looking at the bottom of our drawing, we have a concrete slab laid underneath the filter. This will ensure that no contaminants will enter the filter or the purified water. The media vessel will be elevated above the concrete slab with a row of bricks. This is a cheap and effective method for raising or lowering the filter depending on the container used to collect the water at the bottom. Off-site sterilization is necessary due to the poor sanitation of the general landscape. This will also provide less of a time delay in having filters offline, because they can simply be replaced with a new, ready-to-go filter. This filter is a fast way to purify water collected from water trucks and wells. With the overdrawing of the water table, well water is slowly becoming more concentrated with harmful contaminants, most of which can be removed from the filter media. We believe our filter is a proactive step for making water safer. The strength of our solution is practicality. The people who are facing the majority of the water crisis in India are very poor and are already spending the majority of their earnings for access to clean water. Thus, water filtration must be done cheaply. The barrel and media are estimated to cost $250 initially for parts and installation, with the active carbon being the largest cost at around $100. A key feature for the filter is that it can be managed and maintained by locals with minimal training. Training community leaders may encourage better hygiene practices in villages to reduce self-destructing contamination to their water supply. This is not a complete water treatment system, but for the money, it has the most drastic change on water quality.